It's me again, Levon. We're talking about the Unit 2 now.
Me too, baby. Deuce at your service. What it is. I'm over here.
And my brother here too. Say hi, Patrick.
Baby Deuce here.
You're not Baby Deuce.
Baby Deuce, that's my rap name.
You're not a rapper.
Follow me, Instagram.
Okay, well start rapping.
I'm a killer in the club. Something. I have no bugs. I kill all these people.
What?
My mental destruction. Follow me.
Weirdo. I'll shoot up the school.
No,
Alright. Well, I'm going to describe the Unit 2 assessment. And first, I'm going to start talking about parabolas and stuff and how they relate to real world equations and all that. Put him out because he was just being too much with his little rap career. So, today, we're going to be talking about standard form parabolas. And when you're given a standard form equation and you're given your vertex of H and K. So, in the standard form equation, the A, if it's negative, then it'll be less than the... I need to get my own place. If it's less than -1, then it will be wider. If it's... Shut up. If it's greater than 1, then it'll be narrower. So, for H, if the H tells you which is your X, that will tell you if you gotta move left or right. And the things... Hey, the doggy! So, the K tells you which is your Y, will tell you if it moves up or down. This isn't your standard form. You can use this equation to turn it into your standard form by multiplying everything out and adding all the variables and exponents, and that's how you get your standard form. We're talking about the parabolas, the 4 different parabolas, and then your axis symmetries, your vertex, directrix, and all that. So, when you're given an equation like 30xy equals x squared, you would know that it will be facing upwards because of your x squared. Yeah, because of your x squared and then your positive fraction that's right there. So here's how your parabola could be facing upwards with that equation to the right, and then you have that equation to the left, this equation, and then down. Can you stop? So, you could tell your vertex automatically because for your H value, that's your X, and your K value, that's your Y. Honestly, I don't want your slave feet in my camera. That's disgusting. So, you'll be able to find...
Racist.
It's not racist if you're black. You're black. Knock it off. You're black. Knock it off. You're crazy. You be quiet. Yes.
Oh, well, stop telling me to say all this stuff just for your camera.
Anyway.
Now you're gonna have to do it.
So you'll have to so you can easily tell your vertex and your focus point because your p-value, which is right here, tells the difference from your vertex and focus point. So for this equation, your p-value will actually be 4 divided by 36, which is 9. So from your vertex, 0, 0, your focus point would be 0, 9 because of your p-value, which is 9. And then your directrix is 0, -9, because your directrix is the same value from your vertex as your vertex is your focus point. And that's how you find your focus point, directrix, and axis of symmetry. Oh yeah, my bad. Your axis of symmetry is the line that cuts your parabola in half. So in this case, your axis of symmetry would be x equals 0. For this one, it will be x equals 0. For this one, your axis of symmetry will actually be, my bad, I made a mistake. Your axis of symmetry actually be y equals 0 for a parabola going up or down. And then when a parabola is going right or left, it will be x equals 0, because those are the lines that cut your parabola in half. So I need to fix that. So your directrix will be x equals -9, your axis of symmetry is 0, and your focus point is 0,9. And that's it for today. Thank you for watching. So do you like wear the same shirt and underwear every day or something? Or just nasty.
Oh, that's what you doing. Oh, you really annoying. You gotta know.
So today we're going to be talking about how real world quadratics can help you determine what your best price of an item is and how many items you're going to sell. So here's our problem. An electronical store sells 70 digital cameras per month at a price of $320 each. For each $20 decrease in price, about 5 more cameras per month or so. Use a verbal model of quadratic functions to determine how much the store should change per camera to maximize monthly revenue. So, in terms of this, the first thing you want to do is determine your current revenue, which will be $300, $320, which is the price of the camera, times 70, which is how many cameras they sold per month. So their current revenue is $22,400 a month. It's a lot of money. And the second thing you want to do is determine an equation to find their max revenue, which would be 320 minus 20, because you decrease the price, 20x, because you don't know how many times, multiplied by 70, which is the camera, plus 5, because you gain 5 more customers once you decrease the price, 5x. X is the number of prices change. So for your step 1, you want to find your x value plot, and you'll do that by taking each of the equations and putting them in a zero product property, which would be 320 minus 20x equals 0, and that'll come out to x equals 16. And your second one, 70 plus 5x equals 0, and that will come out to -14. So then you want to plot those at -14, 0, and 16, 0. Now, your step 2, you will want to find your axis of symmetry, and you'll add up your x values, so 14 and 16, and you'll divide those by 2, and then you will see that you will get 1. So your axis of symmetry will be right here. Misdrew it. So then step 3 is to find your vertex, which is, by the way, your x value will always be a part of your vertex. So, my bad, I meant to say your axis of symmetry is the same as your x value. So since x equals 1, you'll plug 1 back into your equation down here. So 320 minus 20 times 1 multiplied by 70 plus 5. So your y will equal to 22,500. So that will be your vertex. 1, 22,500. So for that, you can analyze, which will be your max revenue is 22,500. So that will be $100 more per month, which was your current revenue. So you're going to make $100 more. The best price would be to sell at 300, and your expected sale is 75 cameras a month at a cost of $300 per camera. And that's how you find your best price of an item. And alright, so it's me again. And today, instead of talking about real world parabolas with prices increasing and decreasing, we're going to be talking about real life equations of quadratic regressions. Patrick, I'm doing my thing.
Oh, bye.
Okay, I'm doing. Honestly, God, my bad. So we're gonna be talking about what was that? Quadratic regression of miles per hours versus miles per gallon. So the graph tells us to. What are you doing? Get out, you weirdo. So the problem says the table shows fuel efficiency of a vehicle at different speeds. Write a function that models the data. Use the model appropriate the optimal driving speed. Okay, so dealing with an equation like this, you want to first enter your data. Oh no, first one hit stat on your calculator, and then enter, and then input your data. So once your data is input inside the calculator, you will then want to hit your y equal. Make sure your plot 1 is turned on. And then you want to hit zoom. Go down to number 9. And that will show you your plots. But you can't stop there because now you have to go back to stats, go to the right, and then hit your quad regression, which is number 5. And then you want to go down to calculate. And then it'll give you your A, B, and C. So you'll want to write your A, B, C down somewhere later, like right here on a piece of paper. So that way you can transform it into your y equals ax plus b, bx plus c inside your y equals. So let's do that. So now we have input our data inside the y equals form. You want to hit graph, and that should give you your line. So in order to find your optimal driving speed per miles per hour, you have to now hit second, calc, and then you want to go down to maximum to find your maximum for your vertex. And now left bound, you want to go to the left, hit enter, and now you want to go to your right, hit enter. Now I was going to say you wanted to guess for your vertex or your maximum, and you want to hit enter. So your maximum is 48.78, and okay, this is your vertex, 48.78 and 26.17. Now that you have your vertex, you want to interpret it. So since your x value is your mile per hour, you'll want to round that because on the freeway you don't see 48.78. So you round it to 49 miles is your optimal driving speed per hour. And that's how you find your optimal driving speed using quadratic regression.